So, because I'm just trying to illustrate it and jog your memory, let's go for a nice simple example, okay? So, suppose they ask you to solve sine x is a half, and they'll provide a domain until we get to general solution, which is a couple of weeks away, okay? So, for instance, x. Actually, we'll go with radians. Okay? So, domain supplied in radians, so make sure you put your answer in radians. If you're the kind of person who's still struggling a little bit to get your brain into radians mode, and your sort of instinct at the moment is to convert to degrees in your head, solve it in degrees, and then at the last step, put it back into radians. Can I tell you, now is the time to stop. What will happen is, you'll be like, okay, I'm solving questions so much slower, and I'm even getting some wrong because I'm not familiar with radians. Guess what's the only way to get familiar with radians? Just do the work in that from the get-go, okay? So, there are two ways to solve this. We can do this graphically, or we can do it by quadrants. Okay, so I'll show you both. I'm going to start with graphically, okay? Sine x, what does it look like in this domain? This is the whole period, 0 to pi, okay? So it's going to look like this. All right? Now, because I'm solving, what I'm really asked to solve is this. Okay? So it doesn't matter if my graph looks awful. It just needs to be good enough so I can get an idea of what the answers will be. Now, tell me, what's the range of sine? What's the bottom? -1, and the top is? 1. Good. So therefore, if I'm trying to solve sine x is equal to half, get your ruler out, put where half is, okay, and pop a line through it. Now there are my two solutions, okay? So even if it's a pretty awful drawing, if it vaguely resembles a sine curve, you've already got a general idea of where your 1, 2 solutions are going to be. Okay? Now, then you want to think about your exact values. Sine x equals a half. What's the exact value I'm after here? In radians. Pi on 6, good. So, does that look like it could be pi on 6? Yeah, it matches, because this is about pi. Sure enough, that does look like about the 6th away. Then, using symmetry, you can see, to get this solution, I've gone pi on 6 that way. So to get this solution, I'll have to go pi on 6 the other way. So pi minus pi on 6, that gives you, there's my solution. Okay? So I can say, on the graph, that's a comma, x is equal to pi on 6 or 5 pi on 6. It's not and because it can't be both at the same time. Okay, now let's come over to this approach, quadrants. You still take the same approach at the beginning when you think about your exact values, right? So you would say sine x is equal to, you might actually say sine alpha is equal to a half. So I'm trying to think of what's my base angle, okay? So that'll be pi on 6, okay? And then you draw your quadrants out, right? Now, what do these letters mean? They're referring to which functions are positive in which quadrants, okay? So all the functions are positive in this quadrant, sine is positive in this quadrant, and you get the idea. So pi on 6, what does that look like? That's going to be this first angle here. And then you come back to what you originally wrote, okay? And this value shows that sine is positive, right? So I can't be in either of these quadrants here, so I ignore them. Okay? So then I have to say, in this quadrant, what does pi on 6 look like? It always comes from the horizontal. Okay? So pi on 6 that way, and you can see it's analogous to looking at the graph and going to the left a little bit. Okay? So pi on 6 going up a bit. The actual answer, or rather the actual angle that's the answer I'm after, is this obtuse angle, right? And that's the 5 pi on 6 that I got before. Okay? So from there I can say, therefore, okay, any questions? Yeah.
Do you have to draw the quadrant or can you write sine?
Okay, do you have to draw the quadrants? No, you can say, as sine alpha is positive, therefore, first and second quadrants. They're kind of like equivalent statements, okay? However, most people when they're trying to work out what these angles are, they draw the quadrants anyway, and they're about the same time. Daniel?
Do we actually have to draw that? Because Oh, you just like right answers.
Yeah, okay, so,
I would just write out the two answers.
yeah, all right. Now, for a question like this, because it's so standard, right? Like it's a simple example. I think you would be fine coming down to here, okay? But you throw in a negative or something unfamiliar, or if it's squared, sine squared x equals a half, so you're going to get 1 on root 2 plus or minus 1 on root 2, etc. You're really not doing yourself a favor if you ignore this step, because you're just going to open yourself up to forget solutions or pick the wrong quadrants or something like that. And of course, the other guide is how many marks is it? Okay. I would expect this. Yeah, it'd be 2. It'd be 2. Okay. So
Would that just be like
1, 2. Okay. But here's the thing, right? If you get these wrong and that's all you've written, it's game over. Whereas if you've got this and this is wrong, I can still pay you something because it's like they sort of had the right graph. They just made some fundamental error. Does that make sense? So in the end, I mean, the general rule is taking shortcuts tends not to be a shortcut usually. Okay. Now, just personally, I prefer the graphical method way over the quadrants method. Here's my reasoning. People usually don't like the graphical method because they're like, graphing takes forever, okay? But you can't get away from graphing. You must be good at graphing. If you're going to be an Extension 1 student, then you're not going to escape graphs, okay? So you might as well get good at it. And secondly, I find it more reliable, right? When you want to put in a half, you're not going to mistake which quadrants it is because it's like bang, bang. It's not like, oops, it must be this one. Like your line doesn't even go there, okay? Whereas this one, sometimes I forget which one I'm going, or I'll do something silly like put that there, and then think, oh, the angle's this one instead of the other way around. I find that confusing, okay? But either method is totally valid. Use whichever one you find more comfortable, and whichever is faster for you.